I am from Upvest. Upvest is a BaFin regulated fintech, and we are an investment B2B bank. We currently partnered with Revolut, so we basically take care of the stocks, clearing, settlement, all of it. From the finish, from the starting to the finish. If you don't have a banking license, you can use ours, and that's how it goes. So this is the agenda for today, and I just wanted to make sure that you know what you're getting into. And we will talk about Docker security, but this is what comes to my mind when I started at learning Docker. I'm sure all of you here know what Docker is, So either you're in one of these stages, it's you just had food in them, you read them about TechCrunch, you sometimes run them on your laptop, you run production workloads on them, or you contribute to CNCF. So if you can join me on Slido or not. So get a vibe of the audience. You can go to slido.com and put that number and it'll just give you the options. I think I have to enable that. Yes, so is it, yeah, you can vote. Okay, you can see the results. Well, 100%, okay, changing. I like it. I'm sorry, it does not integrate with, but you can see the results on your phone, so yeah. So yeah, we have pretty good audience. Okay, it's changing. We'll give 5 more seconds. Lunch people are decreasing now. Okay, so we have 25% who have lunch, 50% are running in production, and 7% locally. 8% of them are in CNCF. I would like to meet you guys after this. So yeah, so what is a container? That's my talk. I want to start with the basics because initially I thought, let me just give you a brief 4 points that Docker writes on containers and bore you to death after lunch so that you go to sleep. Or I can just start with the basics, what a container is, and let's see how that it's a food for thought for you. Okay, yeah. Then because it's container, then it comes to the security part of it. What is security means to you? I will just let this, okay, vote for 5 seconds and then we'll let this go. Okay, show results. Okay, 100% developers. Come on, that's going to go down. We are security, we don't like developers. Okay, 50%. Okay. Okay. Yeah. I know that was a bad joke. So these are the 4 bullet points that Docker lists on their website. So when I say Docker, I am basically talking mostly about the Docker container, but it applies to containers in general. So the Docker says that these are the 4 basic points for Docker security. But in a 30 minutes talk, I cannot talk about any of these. So we're just going to talk about what is a container. Container are just processes, they are just normal processes. Docker, Podman, Colima, there are different tools that have made it easier for us to interact with the processes with a level of complexity that we don't have to worry about, right? So I'll just show you a demo how we can use current Linux processes to integrate with, to run and manage Docker containers. So if you see here, I'm just running, it's a Ubuntu system, and we run to see if there is any Nginx process running. Currently, there are no Nginx processes running. And then I'm running a 123.1 Nginx and as a daemon. You see that. After that, I'm just going to run the same command, and you see there are 3 processes. One of them is a master process, 2 of them child processes. Now the question is, how do we know these are Docker processes? They can be any processes, right? So now I run docker ps to show you that it is a Docker process running. But then you can also run Docker with a -forest option, where it shows you the graph of which are the parent processes that it comes to. So if you run this, you'll see the last 3 lines, which is basically container shim run vc. Basically says, because Docker in the background uses container d, that uses run c. So you'll see that. And if you run this last command again, you see both of the process number match. So that basically is that, these are the same processes that Docker is running. So what you can do is, instead of running Docker ps, you can also run the Linux system tools to manage Docker processes. The other thing is, about the proc file system. The proc file system is basically a file system that has details about all the running processes on the Linux. So if you just take the root process 8567, and I made an error, I let it be because we don't remember all the commands, right? So that's it. So what I do is, the idea is, you can go to the proc file system and check the details about this Docker process that you have, like you would do for any other normal process that we see here. Okay. Yeah, so I run the command again to see. Okay. No, it's the same slide. Sorry about that. Yeah. So, okay, yeah, I run the command again to see the Docker process IDs, which will be same 8567. Yeah, and then we'll go to the PIDs, process IDs / yeah, okay, no. So what I'm doing here is I'm going to add a file to Docker. So either you can run a Docker exec ls, or you can do this. Basically, whenever you run this to process ID 8567 / root / whatever the file name is, it will be created inside the container. But you're not using any Docker tool to do that. You're doing it via common Linux processes. So now we'll just run a docker ps. This is the command, and then we'll exec into the container and see if my test file is there or not. So hopefully, yeah, it's there. You can see I'll just highlight it. Magic. So you can just run normal Linux processes to interact with Docker. And just because we can run normal Linux processes to interact with Docker, I'll also show you that you can just kill the process using sudo kill, and it'll actually kill your Docker process. But I would not advertise doing that, because if you have a restart policy in Docker, then it just messes that up and it keeps on restarting. So you should kill it. But the idea was to show you that you can do this via using normal Linux processes. Okay. Okay, I'm running a bit slow. So yeah, okay, this is 12. So the idea is, you have seen that it's basically containers, right? And if all of the if everything is a container, if everything is a process, every container is a process, then how do you isolate? How can one process not talk to the other process? Or we have the noisy neighbor problem, like one process eats up the whole memory or the CPU, and then we are doomed, right? So what do we do is, we are going to the next isolation layers that we have, namespaces. So basically, Linux has a lot of these isolation layers with namespaces, capabilities, control groups, AppArmor or Secure Linux, and SecComp, secure computing. But we are only going to talk about namespaces here, and I'll just throw in some capabilities because I don't have time for the rest of it. So in Linux, you have 8 namespaces. Right, and out of 8 of them, Docker actually implements 5 of them. So these are the namespaces that we have, and out of these 8, Docker will implement 5 of them. And then what you want is, is because I like my class with demos, so you can just see the namespaces. Isn't that good, right? So where is it? Come on. Yeah, the lsns utility is a part of the util Linux package that you can install and run. So when I ran lsns by default, it was just showing me from the user space. When I ran it as sudo, it is showing me from the what do you call for the whole system. Now if you see, we have cgroups, PID, user, UTS, IMP, whatever, all of those things. Now if I run a container, that number is going to increase, because when you run a container, the 5 namespaces that for the container that is created, so it changed from 119 to 125, and you could also see the processes that started with it. So obviously the C groups one are at the top, but the MNT, UTS, IPC, PID, net, these are the 5 namespaces that the Docker created for this. So, and what the namespaces do are they basically restrict the process's view of the container, of the host. So they can be helpful for securing the containers, but the idea is if you want to do security, you have to understand all of these layers, because it's like a Swiss cheese thing. Once you understand all of them, then you can mitigate all the risks that are associated with this and also secure them. So yeah, let's go next. Okay, so now, yeah, so I'll go in very brief detail about all of these namespaces one by one, and then we'll call it good. So first of them is mount namespace. So mount namespace is basically, to use mount the root file system or other file systems. And then what I'm going to show you in the next demo is basically a mount namespace. So when we do this, it plays. Yeah. So when you run docker ps, basically the same container is running. And then what we'll do is we know the process ID, which is 8567 now. I'm sure you remember that. But you can also find that using docker inspect command using state.pid. I should talk a little bit slower. Yeah, then you pass the container name and it will just give you the process number. I want to do a demo, but I didn't know. Yeah, oh, okay, it's a different one, sorry, 9012. Then you just pass the process number using findempty, and it will just show you all the processes. Let me just pause you right here. So if you see, the first one that you have, /overlay. Overlay is the file system that Docker uses. I'm sure all of you are aware of that. But it is there in var lib docker overlay, right? And then you have the rest of the file systems. Now, going by our process methodology, we can also find this data in the proc file system. You want to see that how? It'll be there in /proc, the process ID, /mount info. So we will just do that. So all of these are basically, so it does not interfere with the host part of it. So we will just go on, type. This is my Alexa. Not funny. Yeah. So you can see the cat. I'll do /pid /mount info, and you'll get the same details that you got there, but obviously it's not as pretty printed as it is. But yeah, let me just show you where it is. Yeah, if you see here, /var lib docker overlay, which is the / file. I think it gets better because I just decrease the screen size. Yeah, the /overlay that you have on the top, and then yeah, so you can see all of those details using standard Linux processes also. Like you don't have to use Docker, you just get to know the internals kind of a thing. Okay, the next one that we are going to do is, yeah, there's also one thing. Docker has written a tool, nsenter, that you could use that also to integrate with the namespaces. I think it's also part of the Linux util Linux package, so that you can use that too, but I don't have time, so I've not put that in the demo. Okay, what is this? next. So the next is the PID namespace. So the PID namespace basically gives you an isolated view of the other processes running on the host. So so the one process does not affect the other process, and it can also be helpful in troubleshooting other processes. So instead of running a Docker exec, you can just go to the /proc/ whatever the PID is /root, and then do your investigation if you have to do that. I have a short demo for that too. Okay. Yeah, so here what we are going to use, we are going to run busybox and the top process, because I want the container to run and not exit like the last time. And we'll call it busybox, busyback. And obviously it was not there, so it just started running. Now what we will do is we'll run the inspect command again to find the process ID. And then we will use ns-enter here to go into this container and see how many processes are running in that. So if you see, you will get a process ID, and now we'll use ns-enter. ns-enter. I can get you these documents or a link to that. I have a recommended reading section at the end of it if you're interested in further reading this. So we put the target process ID, and then -m is used to mount the file system, -p is for the process, and then pf -m-p says that we have mounted both of those namespaces. And you see the first one is root, which is basically our top, and the second one is ps-ef. If you ever run a Linux command, both of them will show up because the last one is always there. Just because I ran that. Yeah, so yeah, anything else? Yeah, you can also use the Linux unshare utility to use that namespaces, but that is not displayed here. Yeah, this is the network. So this provides access to the network interfaces, and it's very useful for ensuring that processes can run in their bind ports without needing root privileges. It uses capabilities in short, but and you can also use again ns-enter to find the IP address of the container without going into the container. So that's how we do here. You can also use netns and tcp dump if you had a lot of time. Then we could do those things and run a tcp dump and see how this process, like if you're running an nginx, then how the nginx is connecting to the outside world. It will show you the bind ports and all of those details. That will be here. So yeah, this is just the loopback address. And yes, so what we can do is we can also share their process IDs. So let's say you want to debug a container, right? That is already running. So you can run another container with the same namespace of the PID, and that's how I think the dash tools are implemented. So they could share the same thing, and you could debug that. Okay, 24. The other one is a control group. This is for the this is for the noisy neighbor problem. The control groups are basically, you cannot change much for the control groups, but they are used to put process limits, like how much memory or CPU. It's like you run a container and that container is taking whole of the memory for that specific host, and it crashes the host. So the C groups are used to take care of that. So we'll run Docker Ubuntu, and we'll just list the number of C groups that it has. And in this case, it is 195 because I'm not running a lot of processes. Yeah. Then we have IPC. The IPC namespace is not usually used in a lot of places. It's mostly for POSIX queues and stuff like that. So I don't have a demo for that. Sorry about that. Then we have UTS. So UTS is basically is commonly used namespace, and it's only for the the host namespace that you have. So I have a very good demo for you for this one. So what we can do is we'll run an Ubuntu, and then you see I am root at that Ubuntu. But if you share the host is UTS with the container, you'll get the host name directly. So if you write UTS equals to host, then if you log in and see, you see the Docker security and Docker security, which basically the same host name. You can do that by sharing the C group namespace with this one. Okay, 29. This is one of the newest namespaces that we have. This was introduced in 2020. So if you have what you call Ubuntu 20.04 or 0.10, 04 is the LTS release, you would not find this in that because it was introduced in 2020. So if you want to debug, so you can get it in 2022 LTS. So what this can do is, it is basically for time settings of the underlying host. Let's say you want to go back in time or go future in time and test something, then you can use this namespace to test those things. Or if you want to do a forensic investigation and pass that time and see how that plays out, that can also be done using the time namespace. So I think I have a demo. Yeah, I did with 2022. You'll see the host name change from to instance 1 because I tried that in 2020 and it doesn't work. So that's the reason. So if you see that, you run uptime -s, so you get the current time, which obviously I did this yesterday. And then if you run unshare with the boot time flag of this, so it shows you the difference, which is January with the same command, but you have a different output because I go back in time for that amount of time. So you can use that to do that. Okay, I still have a lot of slides left. This is the user namespace. So the user namespace is one of the most important for running a user process. From a security perspective, it allows the process to be root inside the container without being root on the host, if it makes sense. So like you're installing, let's say, Vim, for example, inside your container to debug something, because it does not have that. So this will allow for you to install Vim inside the container, but not on the host. So I have a demo for that. Yeah, so we have the same. I'm running unshare, and if you see this, yeah, it started. Nope. Yeah, if you see this, I'm running the unshare. Basically, that use says that change the user namespace. And if you see, it shows who am I? I am root. I did not do sudo. I am root. But you can say that, hey, this is a privilege escalation. Like you're root now, you can do whatever you want. Then actually, I open a different session of the same thing. And if you run the I'll clear this first, and then I'll run the PS, and the command will show you that the actual process that is running, unshare fork PID, is running as Piyush. It's not running as root. So what you see is I am root in the user namespace, but I'm not actually root on the system, if it makes sense. It does, actually. So, and then if you want to delete one of the files, let's say etc host, for example, because only root can delete that, you'll get an error because, hey, you're not root, you're just looking like root. He's an imposter. So, fake root. Yeah. The last one is capabilities. I wanted to talk about this, but then I'm already, yeah. So there are 41 capabilities in Linux kernel. So as of today, so you can use the set GUID and get GUID functions to change the process binary. And I don't have this covered. I just wanted to give you for food for thought. So it's like, how does my container run, when it has root, but it's not able to install that? It's because of this. So you can use the pscap example to, get the capabilities that a process is listed. When you run pscap, you'll only get the capabilities that the privileged process has. If the process has no capability, then pscap will list nothing. So, and then this is the recommended reading. This book is very good. If you want, you can just take a note of it. All of that I said and more is there in this. And you have any Q&A, because I won't be there for the round table because I have a leave. So this is the time to ask. 6 minutes. I'm sorry I was running. If you have any questions, please ask. Or you can ping it on LinkedIn. Everybody understands everything. This is what I wanted.